In this video, we will be discussing my June 2025 Pure Mathematics 1 questions for the exam 12, and the subject code is 9709. Okay, we start from question number 1. It says that the diagram shows a graph with equation y is equal to f of x and y is equal to g of x. Describe fully a sequence of two transformations which transform the graph of y is equal to f of x to the graph of y is equal to g of x. Make clear that the order in which transformation must be applied. Okay, so we have to find the transformation from f of x to the g of x. Okay, we have to make sure the order of the transformation. If we switch the order, the transformation will be changed. So we have to take care of the order. Okay, when we observe this graph, there is only 1 unit change. Similarly, here graph is changing 3 units. 1, 2, 3. Okay, when we observe g of x, it is changing 2 units in this here, and 1, 2, 3, 4, 5, 6 units here. So we can say that when f of x changing 1 unit, g of x changing 2 units. Similarly, when f of x changing 3 units, g of x changing 6 units. So we can say that there is a stretch in y direction by the factor of 2. Okay, so it is clear that the stretching in y direction by factor 2. Now we observe how much the vertical transformation took place. Okay, before stretching, how g of x look like? It is -4. So divide by 2, it should be here, and -2 divided by 2, it should be -1, and -8 divided by 2, -4, it should be here. So before stretching, g of x should be like this one. Okay, so how much it has moved from this position to this position, or we can say that what is the translation? It should be 1, 2, 3, 4, 5, 6, 7. So before stretching, it has translated 7 units from here to here, and then it was stretched by 2. So we can say that the vertical translation by 0 to -7, then stretch in y direction by factor 2. Okay, let's move to the question number 2. Okay, we are going to solve the question number 2, which says that find the coordinates of the point of intersection of the curve and the line with equations. This is the equation of curve, and this is the equation of line. So we need to find the point of intersection. We know that to calculate the point of intersection, we need to solve the given equation simultaneously. So from the equation of line, x is equal to, we switch the y and 4 on the right side. So -y minus 4 over 2. We plug this value of x in equation of curve, plug above value of x in curve equation. So what we will have 2x, which is -y plus 4 over 2 times y plus 5y square is equal to 24. Okay, 2 will be cancelled out, and this will become -y square minus 4y plus 5y square is equal to 24, and 5y square minus y square, it will become 4y square minus 4y, and we switch 24 on the left side, and then it will be equal to 0. we take common 4, so this will become y square minus y minus 6 equals to 0. So this will become quadratic equation y square minus y minus 4, 6 equal to 0. And this quadratic equation can be solved using quadratic formula or by factorization. So factorization is easy for given equation. So we can say that y square minus 3y plus 2y minus 6 equal to 0. And we take common y minus 3 plus 2, y minus 3 equal to 0. And this y minus 3 common from these two parts of these two terms. So y minus 3, y plus 2 equals to 0. So we solve it further. We will have two values, y minus 3 equal to 0 or y plus 2 equal to 0. So y will be equal to 3 and y equals to negative 2. So we have y coordinate. Now we can find the x coordinate by plugging this value of y in equation of line. So equation of line is plug values of y in line equation. X is equal to y plus 4 negative over 2. So for y equals to 3 and x will be equal to negative y, which is 3 plus 4 over 2, and this will be y equals to negative 7 over 2. Okay, and when we plug the value of y equals to negative 2 in this equation for y equals to negative 2, so x will be negative 2 plus 4 over 2, and this will be equals to negative 2 plus 4, which is positive 2 over 2, and multiply by negative 1, so x is equal to negative. So we can say that point of intersections are negative 7, 3 and negative 7 over 2, and y is for the value of y 3, and second point of intersection is negative 1 for the value for the y is equal to negative 2. Okay, let's move to the question number 3. It says that the coefficient of x to the power of 7 in the expansion of px square plus 4 over px to the whole power of 5 is 1280. Find the value of constant p. So this expansion involves x square here and x. So we cannot get directly the coefficient of x to the power of 7. So we will apply the general formula, which is tr plus 1 is equals to n combination r a to the power of n minus r and b to the power of r. Okay, and in this case a is equals to px square and b is equals to 4 over px. So tr plus 1 is equals to the, and n is this whole power, so 5 combination r a to the power of n minus r, which is px square to the power of 5 minus r, and b, which is 4 over px to the power of r. Okay, for what value of r we will get x to the power of 7. So we plug x to the power of 7 here is equal to, we are not concerned about the coefficient, we will retain the value of x. So this will become the x to the power x square to the power of 5 minus r, and here x is equals to x to the power of r. So we solve it further. So x 2 times 5, which is 10 minus 2r, and x to the power of r, and here on the left side it is x to the power of 7. We know that basis in power will be added, so x to the power of 10 minus 2r plus r, and this will become x to the power of 7 equals to the x to the power of 10 minus r. Comparing the powers, it will become 10 minus r equal to 7, and r is equal to, we switch r on the right hand side, and this will become 10 minus 7, and r is equal to 3. So for value of r equal to 3, we will get coefficient of 7. So we will fill up a value of r3 in this equation, sorry. T3 plus 1 is equal to 5 combination 3 p x square to the power of 5 minus 3, and 4 over p x to the power of 3. Okay, so this will become r d4, which is equal to the 5c3, which is 10, and then px square to the whole power of 2, 4 cube x cube over p cube. We solve it further, which is equal to 10 p square p to the power of 4, 4 cube times x cube over p to the power of 3, which is equals to the t4. So p will be cancelled out. When we solve it further, it will become 10 times 4 to the power of q times x to the power of 4 times x to the power of 3 over p, and we solve it further. So 10 times 4 to the power of 3, which is 64, x to the power of 4 times x to the power of 3 is x to the power of 7 over p, and this will become 640 x to the power of 7 over p. So we have coefficient of x to the power of 7, which is 640 over p, and which is given also the coefficient of x to the power of 7 is 1280. So we can say that the coefficient of x to the power of 7 is 1280. So we can say that 640 over p is equal to 1280. So we can calculate p, which is equal to 640 over 1280, and this one is equal to 1 over 2. So we can say that p is equal to 1 over 2. Let's move to the question number 4. It says that a point P is moving along the curve with equation this in such a way that its x coordinate of the P is increasing at the rate of 5 units per second. We need to find the rate at which y coordinate of the P is changing when x is equals to 9. Give your answer in terms of A. Okay, so the P is following this curve trajectory in such a way that its x is increasing with respect to time 5 units per second. So we can say that rate of change of x is increasing with respect to 5 units per second. Okay, and the equation of curve given, which is the equation of curve is y equals to ax to the power of 3 over 2 minus 12x, and we need to find the rate of change of y coordinate of t. Means we have to find dy over dt when x equals to 9. To find the value of dy over dt, we can use chain rule, which say that dy over dt is equals to dy over dx times dx over dt. So dx will be cancelled out, and you will get dy over dt. So what we need to differentiate the curve equation. So differentiate the curve equation with respect to x. So dy over dx is equals to the derivative of ax to the power of 3 over 2 minus 12x with respect to dx, which is equals to dAx to the power of 3 over 2 over dx minus d12x over dx. So a is the constant, so we can say a derivative of x to the power of 3 over 2 is 3 over 2 times x to the power of 3 over 2 minus 1 minus 12 constant and dx over dt is 1. We can solve it further. It will become 3 over 2a x to the power of 3 by 2 minus 1, which is equals to the 1 by 2 minus 12. Okay, this is dy over dx. Okay, so if we say this is equation 1, so we can plug well dx over dt this value and this value in equation 1. So we will get dy over dt is equals to dy over dx, which is 3 over 2 times a times x to the power of 1 over 2 minus 12 times dx over dt, which is given 5 unit. So further solving, we can get 5 times 3, which is 15 over 2a x to the power of 1 by 2 minus 60. So dy over dt is equals to the 15 over 2a x to the power of 1 over 2 minus 60. And it says that we need to find rate of y when x equals to 9. So we will plug x equals to 9. So dy over dt is equals to 15 over 2a 9 to the power of 1 by 2 minus 60, which is equals to the 15 over 2a 9 to the power of 1 by 2 is 3 minus 60, and this will become 15 3s are 45 over 2a minus 60. So dy over dt in terms of a is 45 over 2a minus 60. Now let's move to the part B, which says that given the curve has minimum point when x equals to 1 over 4, find the value of a. So this curve has minimum value at x equal to 1 over 4. We need to find the value of a. So we know that minimum condition satisfied dy over dx equals to 0 when x is equals to 1 by 4. So dy over dx we just calculated here. So we just use that one. So dy over dx is 3 over 2 a x to the power of 1 by 2 minus 12 is equals to 0. Okay, here x is 1 by 4. So we just plug x equals to 1 by 4. We will get 3 over 2 a x, which is 1 by 4 to the power of 1 by 2 minus 12 equals to 0, and this will become 3 over 2a, and square root of 1 by 4 is 1 over 2 equals to 12. We just switch the 12 on the right side, and this will become a is equals to 12 times 4 over 3, and 3 fourths 12, and a is equals to 16. So we just calculate the required value of a. Now let's move to the question number 5. It says that the equation of the curve is y is equal to 4 cos 2x plus 3 for all value of x from 0 to 2pi. State the greatest and least possible value of y. So we know that the cos of x is less than and equal to 1 and greater than and equal to negative. This is the range of the cos function for value of 0 to 2pi. So we can say that for x less than and equal to 2pi and greater than and equal to 0, cos of x is less than and equal to 1 and greater than and equal to negative 1. Okay, so if angle changed twice, the value will remain same. Okay, because cos function has maximum value 1 and minimum value of negative 1. So when we multiply by 4, the amplitude will increase. So 4 times cos of 2x, it should be 4 and negative 4. And when we add 3 So it will increase the baseline, change the baseline. So we can say that 4 cos of 2x plus 3 is less than 4 plus 3, which is 7, and negative 4 plus 3 is negative 1. So greatest possible value is 7 and least value is negative 1. Okay, now part B, which says that sketch the curve. So if we consider this one is 1, 2, 3, 4, 5, 6, and this one 7. Similarly, negative 1, negative 2, negative 3. Because we know that the least value of negative 1, so it will be here. Now, when we plug x is equal to 0, because this one is x, when we plug x is equal to 0, we will get 7. 4 cos 2x plus 3, x is equal to 0, then cos 0 is 1, so 4 plus 3, which is 7. When x is equal to 1 over 2 pi, it will become 4 cos of pi plus 3. So it will be negative 4 plus 3, which is equals to negative 1. When we plug pi value, x is equal to pi, it will become cos 4 cos of 2 pi. 2 pi is positive 1, which is 7. So it will be here negative 1, and this one is again 7. So the plot will be like so we will have greatest value of 7 at 0, pi, and 2 pi, and minimum value of negative 1 at 1 by 2 pi, and then 3 by 2 pi, and then 5 by 2 pi. Let's move to the part 3. Determine the number of solution of the equation this and this. So we have already the graph of this equation, which is 4 cos 2x plus 3. Now we find the graph of 2x minus 1. So 2x minus 1. So x is equal to 0. It will be negative 1. When x is equal to 1 by 2 pi, it will be pi minus 1, and which will be 2.142. And when x is equal to pi, it will be 2 pi minus 1, which is equals to the 5.284. So when we plot it, it will be this value. For the value of x is equal to pi, it will be 2.14, which is here. And for value of x equals to pi, it will have 5.2. So when we plot it, this line will be like that. So we know that the solution of two equation is the point of intersection. So from given figure, for x is equal to 2 to 2 pi, from here to here, we have 3 point of intersection. One, this one, and this. For the value of x from 0 to 2 pi, we have only 3 point of intersection. So we can say that from figure, there are 3 intersecting points. So number of solutions are 3. Let's move to the question number 6, which says that the diagram shows the curve with equation this, and the line y is equal to 6 minus 3x. Okay, the line and the curve intersect at the point P, which is given, which has y coordinate. P has y coordinate, which is 3. Okay, find the area of the shaded region. we need to find the area of this shaded region. We have the curve equation. This is the curve which has equation y is equal to 9 over 5x plus 4 to the power of half. Okay, and this line equation is y is equal to 6 minus 3x. Okay, what will be the approach we will going to apply to solve this question? This is the shaded area from 0 to this point. We will find the area under the curve for this region first, and then we will find the area of this triangle. For area 1, we will apply the integration of the curve equation under the limit from 0 to this point. As we know that the integration of the curve under the limit is area under the curve. Okay, and for area 2, which is area 2, we will use the area formula for the triangle because this one is a triangle. Okay, how we can find this value? If we plug y is equal to 3 here in the line equation, we will get the x coordinate. So first y is equal to 6 minus 3x, and y is 3, which is equal to 6 minus 3x, and after switching we get 3x is equal to 6 minus 3, which is equal to 3, and x equal to 1. So this P point has x coordinate 1 here. Okay, and this same line is touching at the x-axis. So if we plug y is equal to 0, we will get the value of x here. So y is equal to 6 minus 3x, and y is equal to 0. So 0 is equal to 6 minus 3x, and 3x is equal to 6, and x is equal to 2. So this is the point 2. Our x coordinate is 2 and y coordinate is 0. So you can see that this one is 2, 0, and P is 1, 3. Okay. Now we find the area 1. For area 1, integration under the limit from 0 to 1. From 0 to 1, from origin to 1, we will get the, if we find the integration under the limit from 0 to 1, we find the area 1 for area. Okay, integration of y dx from 0 to 1 is equals to the 9 over 5x plus 4 to the power of half, and dx from 0 to 1, and this one is equals to 9, and integration of 5x plus 4 to the power of negative half, and dx. Okay, now we get integration of 5x plus 4 to the power of negative half. So integration is 9, and integration is 5x plus 4. So 5 will be divided, and power will be, in power we will add plus 1 and divide by negative 1 by 2 plus 1. Okay, and the limit is 1, 0. So we solve it further. 9 over 5 and 5x plus 4 to the power of half, because negative half plus 1 is half, over 1 by 2, and 2 will be switched in numerator. It will become 18 over 5 and limit 1, 0. So it will become 5x plus 4 to the power of half, and limit is 1, 0. So it will become 18 over 5. Now we apply the limit, which is 5x, which is 5, 1, plus 4 to the power of half, minus, now limit 0 is, which is 5 times 0, plus 4 to the power of half, and this will become 18 over 5, and 5 plus 4, which is 9, to the power of half minus 5 times 0 is 0 and negative 4 to the power of 1 by 2, and this will become 18 over 5, 9 to the power of half, which is 3, minus 2 to the power of 4 to the power of half, which is 2, and this will become 18 over 5 times 1, and area 1 is 18 over 5. Okay, area 1 has been calculated. Now area 2 need to be calculated. So for area 2, so area 2, this is the y coordinate, which is 3, and this is the base, which is 1. 2 minus 1, 1. So we can apply area of the triangle. Area of the triangle is equal to the 1 over 2 length into height, which is 3 times 1, and this will be equal to 3 over 2. So area 2 is 3 over 2. Total area is A1 plus A2. Okay, area 1 is 18 over 5. So A1 is 18 over 5 and area 2 is 3 by 2, which is 3 by 2. So we add it and take the LCM, which is 10, and this will be the 36 plus 15. So if we add up, we get A is equal to 51 over 10 unit square. So total area is 51 over 10 for this shaded area. Okay, let's move to the question number 7. Prove the identity tangent theta plus 7 over tangent square minus 3 is equal to sine theta cos theta plus 7 cos square theta over 1 minus 4 cos square theta. Okay, taking left hand side, tangent theta plus 7 over tangent square theta minus 3. Okay, so we know that tangent theta is sine theta over cos theta. So we plug this value. So we will get sine theta over cos theta plus 7 over sine square theta over cos square theta minus 3. Okay, we solve it further. We take LCM and this will become cos theta and sine theta plus 7 cos theta. And denominator, we also take LCM, which is cos square theta and sine square theta minus 3 cos square theta. Okay, we switch it. It will become sine theta plus 7 cos theta over cos theta and multiply by cos square theta over sine square theta minus 3 cos square theta. Cos and cos will be cancelled out, and we plug cos square sine square theta as sine square theta is equals to 1 minus cos square theta. So it will become sine theta plus 7 cos theta multiplied by cos theta divided by, for the sine square theta we plug 1 minus cos square theta, 1 minus cos square theta minus 3 cos square theta. After multiplying, it will become cos theta sine theta plus 7 cos square theta over 1 minus cos square theta minus 3 cos square theta. It will become 1 minus 4 cos square theta. Left hand side after solving is become right hand side. We can say that Hans proof. Okay, let's move to the part B, which says that Hunt solve the following equation. The left side of the equation we just solved, this is equal to the tangent theta plus 7 over tangent square theta minus 7. So we can use tangent theta plus 7 over tangent theta square theta minus 7 is equal to 5 over tangent theta. We just solve it. This one is equals to this one from last part A. Okay. By cross multiplication, we can achieve tan theta square plus 7 tan theta is equals to 5 tan theta square minus 15. Okay. We just switch left side term on the right side. It will become 5 tan square theta minus tangent square theta minus 7 tangent theta minus 15 equal to 0, and the 5 tangent square theta minus tangent square theta is equal to the 4 tangent square theta minus 7 tangent theta minus 15 is equal to 0. This is the quadratic equation. We can solve it by factorization. Tangent theta 4 tangent square theta minus 12 tangent theta plus 5 tangent theta minus 15 equal to 0, because minus 7 is equals to 12 negative 12 plus 5, and 12 multiplied by 5 is 15 multiplied by 4. Okay, we solve it further. We take common 4 tangent theta, 4 tangent theta, and this will become tangent theta minus 3 plus, and then 5 common, and tangent theta minus 3 equal to 0. We are taking tangent theta minus 3 common from both terms, so it will become 4 tangent theta plus 5 and tangent theta minus 3 equal to 0. As two factor are equal to 0, so we can say that 4 tangent theta plus 5 equal to 0, or tangent theta minus 3 equal to 0. So tangent theta is negative 5 over 4, and we solve it further. Theta is equal to tangent inverse of 5 over 4, negative 5 over 4. On the right side, tangent theta is equal to positive 3, and theta is tangent inverse of 3. Okay, we are just finding the base angle, so we are ignoring the sign, so it can be equal to tangent inverse of 5 over 4. So theta is 51.34. On the other side, tangent theta is 71.56. Now, in question it says that the theta should be lie between 0 to 180. So we know that in first quadrant all angles are positive, and in second quadrant sine, in third quadrant tangent, and in fourth quadrant cos theta is positive. So because due to the negative value of 5 over 4, the quadrant which satisfies the angle condition is lie here in second quadrant. So we can say that theta is equals to 180 minus 51.34, which is equals to the 128.7. Okay, and 3 is already positive, so it will also satisfy the angle condition, because theta is between 0 to 180. So we have solved the given question, and angle arc at 71.56 and theta is 128.7. Now let's move to the question number 8. It says that the diagram shows the circle with the equation given, and the line equals to y is equal to negative 2. The line intersects the circle at the point A and B. The center of the circle is C. Find the coordinates of the ABC. This is origin, and this is the line equals to negative 2. Y is equal to negative 2. Okay, and this line intersects the circle at point A and B. So if we solve this equation, y is equal to negative 2, and the circle equation simultaneously, we can get AB point. Secondly, to find the center of the circle, we know that if we convert this equation into this format, x minus a whole square plus y minus b whole square is equal to c. Then center is a and b. First we find ab by converting this given equation into this format. So given equation is given circle equation is x square minus 14x plus y square plus 8y is equal to negative 36. Now we make x minus a whole square, so we have to make it complete square. So x square minus 14x plus 49 plus y square plus 8y plus 16 is equal to negative 36 plus 49 plus 16. Okay, we just add 49 and 16 on the left side and the right side. So this will become x minus 7 whole square, and this will be equals to the y minus y plus 4 whole square is equal to, and this will be equals to the 29. So the center of the circle, the center of circle C is 7 and negative 4. Okay. Now let's find the points A and B, which is the intersecting point of the line and circle. So we just plug the value of y is equal to negative 2 in given circle equation. So plug in y is equal to negative 2 in circle equation. So x square plus y square, which is negative 2 square, minus 14x plus 8y, which is 8 negative y negative 2 plus 36 equal to 0. We solve it further. X square plus 4 minus 14x negative 16 plus 36 equal to 0. So it will become x square minus 14x plus 24 equal to 0. So this is the quadratic equation. We can solve it either by quadratic formula or by factorization. In this case, factorization is easy because 12 multiplied by 2 is negative 12 multiplied by negative 2 is equal to 24. And when we added negative 12 plus negative 2 is negative 14. Okay. So x square minus 12x minus 2x plus 24 equal to 0. Now we take x common from first two terms. So x minus 12. Similarly, we take common negative 2. So it's x minus 12 equal to 0. Take the x minus 12 common from both terms. So it will become x minus 12 and x minus 2 equal to 0. So x coordinates are x minus 12 equal to 0 or x minus 2 equal to 0. So in this case, x is 12 and in this case, x is 2. So this is point near to the origin. So this will A will be 2, x coordinate 2, and for the y coordinate negative 2. And B will be 12, comma, for the y coordinate negative 2. And C we just calculated, which was 7, comma, negative 4. So we have calculated the coordinates of ABC. Now let's move to part B. It says that find the angle ACB in radian. Give your correct answer in 3 significant figures. Okay. We need to find the angle ABC. Okay. This is the angle. First of all, we know that this C the square root of C is R, radius. So from this equation we can say that the radius 29, radius is the square root of 29. So for this circle, radius is under root 29 and here under root 29. And if we find the distance between AB by using distance formula, as we know the coordinates of AB, so first we find the AB where A is 2 comma negative 2 and B is 12 comma negative. So distance between AB is under root x2 minus x1, which is 12 minus 2 square plus negative 2 minus negative 2 square. So this will become under root 10 square plus 0 square, which is equals to 10. Okay. So we have the distance between AB is 10. So we have the information of all sides of the triangle. If we bisect this, so this will become a right angle triangle like this is the center. This will be B and distance is 10 and we call it P. Okay. This is the right angle triangle and we need to find this angle. Where CB is the radius and distance between PB, which is half of the AB. PB is half of the AB, so we can say that it is 5. We have the information of the opposite side or length of the opposite side, and we also have the length of the hypotenuse. So by using sine wave, sine theta is opposite side divided by hypotenuse, and in this case opposite side is 5 over under root 29. Sine theta is 5 over under root 29 and this will be theta is equal to sine inverse of 5 over under root 29. So we can use the calculator to find it. So theta will be 1.19 radians. So we have calculated this radian. If we make it double, we will find the total angle ACB. So angle ACB is 2 times of theta, which is equal to 2 times of 1.19, which is equal to the, and this will be equal to 2.38 radians. Let's move to the part C. It says the chord AB divides the circle into 2 segments. Okay, find the area of the larger segment. This is the small segment and this is the larger segment, and we need to find the area of this larger segment. We will find the area of this triangle, and then we will find the area of this sector. So total area of the large segment, area of large segment is area of triangle ABC plus area of sector, and sector is this one from here in this. Okay, first we find the area of the triangle. Area of triangle is, we know that triangle, this is A, B and C, and we know that the AC and CB is radius, which is under root 29 and this is under root 29, and we just calculated the angle of ACB, which is this one, and this angle is 2.38 radian. Okay, one of the formula to calculate the area of the triangle is 1 over 2 AB and sine of C. Sine of C is the if A and B are two sides of the triangle and the angle between them is the C. Okay, for example, if we have A, B and C, this is the angle C. If we know the any two sides and the angle between them, we can find the area of the triangle by using this formula. So we will apply this formula in this case also. So we can say that area of this triangle is 1 over 2 radius 29 this side, which is this is small a, this is small b. B is also under root 29 times sine of C. C is the angle which is between A and B. So sine of 2.38. Okay, we solve it further. 1 over 2 129 times 129 is 29 times, and sine of 2.39 is 0.69. Okay, we just multiply, and when we solve it, it becomes 10.0060. Okay, we have just calculated the area of the triangle ABC. Now we need to find the area of this sector. And suppose we have the circle, and this is the center, and this is the small sector which has angle theta. So to calculate the area of this sector, we know the formula is theta over 2, the angle of sector, which is theta over 2 times r square. This is the area of sector. This is the area of the sector. Okay, so we in this case, so area of the sector is angle divided by 2 multiplied by radius square. Okay, the angle in this case is this one, and we know the angle of ACB already. So in this case, angle is 2 pi minus angle of ACB times radius square, which is r over 2. Okay, so we know that angle of ACB we just calculated, which is 2.38. So this will become 2 pi minus 2.38 over 2, and its radius is under root 29 and it is square. So we calculate it. So this one is 3.903 over 2 multiplied by 29, and this 56.59. So total area of the large segment is area of the triangle ABC plus area of the center. So total area, or you can say area of large sector, is area of the triangle, which is 10, plus area of the sector, which is 56.59. So the required area is 66.59, which is equal to 66.6 unit square. Okay, this is the required area. Now let's move to the question number 9. Okay, we are solving question number 9. It says that the equation of the curve such that second derivative of y with respect to x is equals to the negative 24 over x cube. It is given that curve has a stationary point at negative 2, 19. Find the expression for the dy over dx. Second derivative of the curve is given, which is equal to negative 24 over x cube. And we need to find the dy over dx. We know that to find dy over dx is equals to the integration of second derivative dx. And when we solve it further, it becomes negative 24 over x cube dx. We solve it further, it will become integration of negative 24 x to the power of negative 3 dx, and this one is equals to the negative 24 x to the negative 3 plus 1 over negative 3 plus 1 plus c. We solve it further, it will become negative 24 over negative 2 x to the power of negative 2 plus c. So this one is dy over dx. What is the value of c? To find the value of c, we will use the information of stationary point at negative 2 comma 19. This negative 2 comma 19 is the stationary point, so it means that derivative of dy over dx is at stationary point negative 2 comma 19 is equal to 0. It will cancel and it will 12. So 12 x to the power of negative 2 plus c at negative 2 comma 19 is equal to 0. So when we plug value of x negative 2 in this expression, it will become 12 negative 2 to the power of negative 2 equal to negative c, and we solve it further, it will become 12 over negative 2 to the power of square is equal to negative c, and this one is equal to 12 over 4 which is equal to 3. So negative c equals to 3 or c equals to negative 3. So we have calculated the constant, so we plug in this equation. So final expression of dy over dx is 12 x to the power of negative 2 minus 3. This is the required dy over dx. Now part B, find the x coordinate of the other stationary point of the curve and determine the nature of this stationary point. Okay, it's mean this curve has another stationary point. One was negative 2 comma 19 and other one is known, and the x coordinate of that second stationary point need to be calculated. For stationary point, dy over dx is the 12 x to the power of negative 2 minus 3 is equal to 0. So 12x negative 2 is equal to 3 and 3 is 4. 4 over x to square is equal to 1, and this one is equal to x square is equal to 4, and x is equal to plus minus 2. So x is positive 2 and x is negative 2. So in this case, the other x coordinate of other stationary point is x is equal to positive 2, because already negative 2 is the stationary point which was given in the question. Now to find the nature of this stationary point, we know that we have to plug this stationary point in the second derivative of the curve. So dy over dx square, second derivative is negative 24 over x cube, and x is equal to positive 2, second stationary point, so it will become, so d square y over dx square at x is equal to plus 2 is equals to the negative 24 over 2 cube, which is equal to negative 24 over 8, and it is equal to negative 3, which is less than 0. So this is stationary point, so is maxima. So we can say that the other stationary point is maxima. Now let's move to the part C, which says that find the equation of curve. So we need to find the value of the y. So if we integrate this equation dy over dx, then we will get y, which is the equation of curve. So y is equal to integration of dy over dx. Dx is equals to the integration of 12x to the power of negative 2 minus 3 dx, and this one is equals to the 12 integration of x to the power of negative 2 dx minus 3 1 dx, and we should solve it further, it will become y is equal to 12 x to the power of negative 2 plus 1 over negative 2 plus 1 minus 3x plus k and k. Another constant. So we solve it further, it will become negative 12x to inverse minus 3x plus k. So y is equal to 12 negative 12 over x minus 3x plus k. So this is the equation of curve where k is unknown. So to find the constant k, we will use the information of the stationary point which was given. So if we plug this stationary point, because this stationary point also satisfy this equation. So the stationary point satisfy the curve equation part D. So plug negative 2 comma 19. So when we plug negative 2 comma 19, it will become 19 is equal to negative 12 over negative 2 minus 3 over times negative 2 plus k. And when we solve it, it will become 6 and 6 negative negative cancel 6. Negative 3 times 2 is plus 6 plus k is equals to 19 and k is equals to 19 minus 12 and k is equals to the 7. So the curve equation will be, when we plug k in this equation, the curve equation will be y is equal to negative 12 over x minus 3x plus k. So k is equal to 7 to 12, negative 12 over x minus 3x plus 7. So this is the required equation of the curve. Now part D, which says that find the equation of the normal to the curve at the point where dy over dx is equal to negative 9 over 4 and x is positive. Express your answer in the form of px plus qy plus r equal to 0, where p, q, r are integers. Okay, we need to find the equation of the normal to the curve at the point where the derivative of the curve is equal to negative 9 over 4. So it is given y over dx. It is y over dx is negative 9 over 4, and we know that the derivative of curve was 12x to the power of 2 minus 3. So we plug it. So it will become 12x to the power of negative 2 minus 3 equals to negative 9 over 4. We solve it. It will become 12 over x square negative 9 over 4 plus 3, and this one is equals to the 4 negative 9 plus 12, and this one is equals to the 3 over 4. So 12 over x square is 3 over 4. So by cross multiplication you will get x square is equal to 16 and x is equal to plus minus 4. In question it says that x should be positive, so we will take x positive. X coordinate of the point is positive 4. So we need to find the y coordinate of the point. To calculate the y coordinate of the point, we will plug x is equal to 4 in curve equation, this one. So plug x is equal to 4 in curve equation. So curve equation is y is equal to negative 12 over x minus 3x plus 7. So y is equal to negative 12 over x, which is 4, minus 3 times x, which is 3 times 4 plus 7, and 4 3s are 12. So negative 3 minus 12 plus 7. So y is equal to negative 8. So we have calculated the point which is 4 comma 8. This is the point at which normal will be drawn, and we have to find the equation of that normal. So we need the slope of the normal. To find the slope of the normal, we know that the given slope is perpendicular to the slope of the curve. So for perpendicular slope, perpendicular or normal slope m times m normal is equals to negative 1 and given slope is negative 9 over 4. So we plug negative 9 over 4 and m normal is equal to negative 1 and this one is equals to the 4 over 9. Okay. Now we have the slope of the normal and the point at which normal will be drawn. So we by using slope point form, we know that y minus y1 is equal to m times x minus x1. So y1 is negative 8, sorry. So this one is y1 and this one is x1. So y minus negative 8 equals to m, which is 4 over 9, and x minus x1, which is 4. So when cross multiply, it will be y plus 8 times 9 equals to the 4 times x minus 4. When we solve it, it will become 9y plus 72 equals to 4x minus 16 equal to 0, sorry, minus 16. After switching, negative 4x plus 9y plus 72 plus 16, and this one is 4x, negative 4x plus 9y plus 88 equal to 0. So comparing with the px plus qy plus r, this is a format in which we have to express the answer. So p is negative 4, q is 9, and r is 88. Okay, this is the required equation in this format. Now we move to the question number 10. It says that the first, second, and third term of the arithmetic progression is 4k, k square and 8k respectively, where k is the non-zero quantity. Find the value of k. We know that arithmetic progression is a plus d, a plus 2d, and like that. Its nth term is a plus n minus 1 times d. Okay, so first term is given. So a1 is first term, which is 4k, a2 is second term, which is k square, and third term, which is a3 is equals to 8k given. Okay, this and we need to find the value of k. So we know that in arithmetic progression difference is same. So difference is, first difference is second term minus first term, which is equals to the k square minus 4k. Similarly, another difference, which is first term third term minus second term, which is equals to 8k minus second term. So equating equation 1 and equation 2, we will get x square minus 4k equals to the 8k minus k square. So we switch it on the left side, it will become 2k square minus 4k and minus 8k equal to 0, and this will equal to the 2k square minus 12k equal to 0. Take the common 2k and k minus 6 equal to 0 and k equal to 0, or k minus 6 equal to 0, which is equal to k is equal to 6. So we have two value of k, and it is given that k is non-zero, so k equal to 6 is right answer. Now we need to find the sum of the first 20 term of the progression, and we know that the sum of the progression is as n is equals to n over 2 bracket 2a plus n minus 1 times d bracket close. We have here k, d is k square minus 4k, so k square minus 4k. Now we plug the right value of k, which is 6, so 6 square minus 4 times 6, and this will equals to the 36 minus 24, and d is equal to 12. So we have the value of t, we have the n which is the 20 term, so n is 20, and we have the first term a which is 40. So first term a1 which is a equals to 40. So we have all the information required. So we plug n is equal to 20 over 2 bracket 2 time n, 2 time a is to 4k plus n minus 1 which is 20 minus 1 time d which is 12. Okay, this one is 10. So 10 bracket 2 time 4 8k plus 20 minus 1 19 time 12. Okay, okay, we solve it further, it will become 10 time 8k, k is equals to the 6. So this one is 6. So 8 times 6 plus 19 times 12 is 288, and 10 times 8 times 6 is 48 plus 288. When we solve it further, it will become 10 times 276. 10 times 276 is 2760. So S20, which is sum of the 20 term, is 2760. Let's move to the part B. It says that the fourth term and sixth term of the geometric progression is 36 and 6 respectively. The ratio is positive. Okay. Find the sum to infinity. Give your answer in terms of a over under root b minus c, where a, b, c are integers. Okay, we know that the geometric progression is a comma ar comma ar square dot dot dot, and its nth term is ar to the power of n minus 1. Okay, fourth term and sixth term are given. So fourth term is 36 and sixth term is 6. So we know the nth formula. So a r n minus 1 which is 4 minus 1 is equals to 36, and a r cube is 36. Similarly, a 6 which is a r 6 to the power of 6 minus 1 equal to 6, and a r to the power of 5 is 6. Let's divide the equation 2 from equation 1. So divide equation 2 by equation 1. So a r 5 to the power of 5 divided by a r to the power of cube is equal to 6 over 36, and a will cancel out, and this one becomes r square, and this one becomes 6. So r square is 1 over 6. Square root both sides. R is equals to plus minus 1 over under root 6. So it says that the ratio of the progression is positive, so we will take r is equal to positive 1 over under root 6. So we have calculated the ratio. We also need to find the value of a. Plug this value of r in equation 1. Plug in equation 1. So a r cube is equals to 36, which is equals to the a r cube 1 over under root 6 cube equals to 36, and when we solve it, it will become a is equal to under root 6 times power cube times 36, and this one is equals to the 6 under root 6 times 36. When we solve it further, 36 times 6 is 216 under root 6. So first term is 216 under root 6. We have the information of ratio, and we have also the information of first term a. We need to find the sum to the infinity. We know that sum to the infinity as infinity is equal to a over 1 minus r, and a is equals to the 216 under root 6 over 1 minus r. R is 1 over under root 6. Okay, we solve it further, it will become 216 under root 6 over taking LCM under root 6 and under root 6 minus 1. and this one is equals to the 2 under 206 8 under root 6 times under root 6 divided by under root 6 minus 1. So this infinity is 216 times 6 over under root 6 minus 1. Okay, 216 times 6 is 1296 over under root 6 minus 1, and we have the required format, which is a over under root b minus c. So a over under root b minus c. So a is 1296, b is 6, and c is -1 or +1. So this is the required integers, or you can say that this is the required format. Let's move to the question number 11, which says that express x square plus 4x plus 2 in the form of x plus a whole square plus b, where a, b are input. So given is x square plus 4x plus 2, and we will try to make it complete square. So x plus 2a times 2 plus 4 and minus plus 2 minus 4. Okay, we have just add the plus and minus 4. So it will be x plus 2 whole square and then plus 2 minus 4. So we solve it further, it will become x plus 2 whole square minus 2. So in this case, a is 2 and b is equal to 9. Okay, part B, it says that the function f and g are defined as given, in which f of x is equal to x square plus 4x plus 2 for all value of x less than equals to -2, and g of x is equal to -x minus 4 for all value of x which is greater than or equal to -2. Find the expression for the f of x. So we have just calculated the f of x, which is equal to the x plus 2 whole square minus 2. So let y is equal to original function, and we will isolate the x. So 2 whole square minus 2 equals to y, and when we switch -2 on the right side, it will become x plus 2 whole square equals to y plus 2, and square root both sides. So it will be x plus 2 is equal to under root y plus 2, and when we switch 2 on the right side, it will be x is equal to -2 plus minus, sorry, it will be plus minus y plus 2. Okay, so in this case we are having two values. One is -2 plus under root y plus 2, and other one is -2 minus under root y plus 2. So we cannot have two inverse of the function, because for the existence of the inverse of the function should be 1 to 1. So which function will be considered defined by the given values of the x. So we know that domain of the function is equal to the range of the function inverse. So we know that the domain of the function is x is less than or equals to -2. So x should be always less than -2 or always be the negative. In this case, we will having the negative values. So we can say that f of x inverse is -2 minus x plus 2. So this is the inverse of the given f of x. Now we solve the second part, which says that find the expression for g of inverse of x. So first we will find the g of f, and then we will find the gf of inverse. Okay, so here g of x is an f of x. So here f of x is equal to x plus 2 whole square minus 2, and g of x is equal to -x minus 4. Okay, so first we find g of f of x, So it will be equal to the g of x plus 2 whole square minus 2. So in place of x, we will plug this value of x, f of x. So it will be negative x plus 2 whole square minus 2 and then minus 4. So we solve it further, it will be negative x plus 2 whole square, negative negative, plus 2 minus 4, and this will be equal to negative x plus 2 whole square minus 2. Okay, so this is the g of f of x. Now let y is equal to negative x plus 2 whole square minus 2. So we will try to isolate the x. So when we switch x plus 2 whole square on the left side, it will be x plus 2 whole square equals to the negative 2 minus y, and square root both side, it will be x plus 2 equals to plus minus under root negative y minus 2, and when we switch x on the right side, it will be x equals to negative 2 plus minus under root y negative y minus 2. So we have two answers. One is negative 2 plus under root negative y minus 2, and second one is negative 2 minus under root y minus 2. So which one will be considered? So we know that the range of g of f of inverse of x is domain of g of f of x, and the domain of f of g of x is domain of f of x. So what is the domain of f of x? Is x is less than and equal to negative 2. So for any value of y, we should have the negative value. So we will consider this one. So x is equal to negative 2 minus under root negative y minus 2. So we can say that gf of inverse of x is equal to negative 2 minus negative x minus 2. So this is the end of the paper. Thank you for watching my videos. Allah Hafiz.